Hi everyone, welcome to another NLP Insider Live show, and thank you so much for joining us today. We are here live every other week for 15 minutes to talk about everything NLP with industry leaders. My name is David Talby, I'm the CTO at John Snow Labs, and today I'm excited to chat with Harsha Gurulingappa, who is the head of text analytics at Merck Group in Bangalore, India. Until October 2022, so just recently, he was operating from the Merck Group headquarters in Darmstadt, Germany. Harsha has over a decade of dedicated experience in both research and production implementation of text analytics solutions. And today he will share his experience and perspective about NLP and how it can be applied to generate value in the enterprise. Welcome, Harsha. Thank you for coming.
Thanks, David. Yeah, thanks for organizing. Thanks for having me in the call as well. It's a pleasure to be here.
Well, let's jump right in then. You did your PhD in the area of biomedical text mining, and you've been heading a team responsible for text analytics. Can you tell us a bit more about your work and your work within the company and how it fits into the larger Merck strategy?
Yeah, sure. Yeah. So let me start with a top-down perspective. So Merck Group, it's headquartered in Darmstadt, as you already mentioned, in Germany. So we are into three areas of business: healthcare, life science, and electronics. And so I operate within a central function, and we are called as a Merck Data Office, and which is led by a group data officer. And as a group, our main responsibility is to drive a data strategy for the whole organization, as well as to offer a central data analytics ecosystem. And the reason we explicitly call it as a data analytics ecosystem is because it is composed of multiple interesting things. That is, it starts with the technical capabilities platform. So we have technical capabilities in terms of the latest cloud solutions, and of course a couple of open source and also proprietary solutions as well. And they have been so well integrated that from end user point of view, and we want to enable the technical experts in the organization to develop data products, digital solutions, and use cases with scale and speed by minimizing the time to the market. So it's all about a central ecosystem. Let's say the platform part now. Then the next piece is the things around governance and compliance. Since we operate in a regulated environment, it is important that most of the things that we do, most of the products and services we offer, has a direct or indirect impact on the health and life of patients and customers. So, of course, we are strongly obliged to work in a highly compliant environment. So then we also offer services ensuring that the data is securely used, and also when the data or when the results of any kind of analysis are embedded into the business processes, they're systematically well thought through, well documented, and so on, so that we are completely compliant with respect to any kind of policies, regulations, and so on and so forth. Mm-hmm. We also have a data culture group that is more focusing on things like upskilling programs, educational events, building a community in the organization, ensuring that we learn the best practices of how to use the tools and technologies for the best of our businesses. And then we also speak about innovative technologies too, since technology is growing quite rapidly in the market. So we also want to ensure that we don't stagnate with respect to the tech stack that we have at place, and we want to evolve it with all the latest and greatest technologies that make sense for our business. So in this way, we try to be frontiers and pioneers in the market, trying to investigate the latest technologies that are out and ensuring that we are able to complement or augment our existing stack as well. So that's all about the ecosystem. So I would fall into the last category. I spoke about everything are innovative products and solutions, right? So here we focus on multiple interesting things. For example, natural language processing capabilities. How can we offer NLP capabilities for the whole organization so that we are able to best leverage let's say the tools and technologies at hand to generate insights from the unstructured data. We also have other capabilities in the directions of quantum computing. So some of the experts in the organization have been investigating, let's say, how best to leverage quantum computing, which is in a very nascent stage in the market, high performance computing, computer vision, and all these things. So that is basically our main role. It's all about offering NLP as a service to the organization to be able to develop data products and solutions, which is making sense out of the unstructured data.
So you get to play with a lot of cool new toys, basically. So how do you compare your work today versus what you were doing when you started 10 years ago? So what has changed in NLP techniques since you started working in this field?
Yeah. So if I now look back, let's say 10 years before, let's say around, because I started my whole career in NLP roughly around 2007 time. So if I now look back 10, 12 years back, right, around 2010 times. So with respect to the NLP, a lot of things have changed. So maybe let me start with the methodology and the techniques part of it.
Mhm.
So at least I personally remember working with frameworks like UEMA, GATE, Unstructured Information Management Architecture, General Architecture for Text Engineering, University of Sheffield, and so on, right?
Yeah.
There was used to be a lot of emphasis on linguistics, trying to build parsers, for instance, dependency parsing, right, and so on, and trying to apply the linguistic knowledge to kind of make sense out of the sentences, trying to understand the relationship between words in the documents. And I think it was a quite labor-intensive task, if I remember well. And there is a very nice video from Professor Christopher Manning, who is one of the pioneers in the whole field of NLP, and it's a nice YouTube video which talks about deep learning for NLP. And at some point of time, he makes a statement saying that with the traditional approaches and also with the machine learning approaches and feature engineering, and he makes a very nice statement saying that it was not the machine that was learning, but it was the human that was learning, and machine just learned how to draw a kernel or a line between the different examples, uh, just to kind of make the separation in that multidimensional space. And so I think that is how I think the evolution has happened, right? That is a lot of overhead on the experts to kind of create those rules, read the documents, to kind of automating the whole processes to let the machine learn, let's say, the language, learn the semantics, learn the context by itself, which started all the way from 2013 onwards. I think the whole world to wake in 2013, that was one of the largest, let's say, innovations at that point of time. And then eventually that came down to more complex, shallow deep learning models, followed by more transformer models, deep learning models. And now we speak about more generative models, right? I think that's basically one part, I would say, right? Very much centered around tools and techniques. Then, of course, a lot of advancements in the infrastructure part as well. So at least I personally remember working with the grid computing. We used to make things grid compatible and submit a grid jobs, Univa grid engines and all those things, right? You might also remember the same things as well. But now, of course, we have moved to more modern cloud infrastructure, right? So less of the focus on the infrastructure, but more focus on kind of using the infrastructure, automating the things, and so on. Distributed computing, especially what you guys offer in Spark NLP and Spark OCR and so on, right? Making the things more kind of Spark native, for instance, ensuring that we are able to distribute. I think that's one of the capabilities that has significantly evolved as well. And everything around the graphical processing unit, the GPUs, right? So that we're able to kind of train those deep learning models and also to have the faster inferencing times. I think these are some of the advancements that I see from the computing side. Of course, a lot of changes in the business models. At least I remember working with very thick monolithic softwares that can do almost end to end, from data ingestion, data digestion, data transformation, visualizations, all coming as one big thick software stack.
Mhm.
But I think now the business models has also evolved quite significantly. Now I think we speak about APIs, a lot of offerings that we find in the market, purely offering API error services. We speak about auto ML services, right, or labeling services, right, tools where you can just label the data, you can kind of semi-automate, you can use automation learning to kind of train the models in a more graphical, intuitive manner. A lot of services around intelligent document processing systems. Although this has existed since many, many years, I think in the last 3 to 4 years, I think the whole term IDP was invented, and it's all about
Yes.
more around document processing, invoice processing, right? This kind of business process automation has come in. Social media solutions too, right? Although the whole social media space is thickly populated with, I think, hundreds of even of solutions in the market. And also I think this market is also getting more and more concentrated around industry specific solutions. So for example, social media solutions very much focusing on the patients, for example, or any kind of a medical information and so on, right? Or maybe more focused on automobiles and so on.
Mhm.
Then chatbot, right? So in this way I can see a lot of new business models getting evolved from thick monolithic single software into kind of more modular solutions, easy to integrate, providing you very specific solutions for very specific problems. And then I think the trust and the adoption as well, I think that's one of the big change as well. So if I remember, we had a very nice presentation in the organization, and I had a chance to present to a very large audience. And I asked a question like, how many of you use NLP, right, in general, right, either direct or indirectly? And the question was 30-70. So 30% believed that they use NLP, and 70% thought they don't use NLP. And when I said that the answer is 100%, because everything that you're using, for example, in LinkedIn, right, when you're typing in a chat reply to somebody, right, or any kind of spelling corrections that you have in your Microsoft Office engines and all these
Yeah.
things, it's all about NLP. So people were, it was very hard for people to believe that this falls in the category of NLP as well. And here I see NLP kind of more drifting away from being a complementary technology to more being a fundamental technology.
Mhm.
And I think it's getting embedded almost everywhere. I think almost every day we are using NLP, be
Yeah.
it in watches, be it in computers, be it right, voice assistants, wherever, right? I think that's what I see as well. And I think the last thing I see is the multimodality as well. So, of course, things around voice to text to image, research have existed since many years, but I don't think they were so easily accessible. Like, for example, all the diffusion models with DAL-E, right, and all these things. So this is becoming more and more easily accessible even for non-technical people as well. That is kind of creating more and more trust, and also kind of more curiosity, and people to understand how things work, and they want to start using it for the day-to-day life, day-to-day businesses, more artistic creative work as well. So I think in this way the NLP has changed significantly over the last, I think, 10 to 15 years, at least based on what I've been seeing this.
Yep. Yeah, I think there are many more use cases that were just not possible. Yes. Yeah, I think like in intelligent document processing is a good one. You say yes, it always existed, but it used to be focused on just the workflows of the document. Now now your system would actually read and understand the documents, right? So it's
True.
just a different level. Yep. So Harsha, and thank you for this fantastic comprehensive overview. So you and your team have been presented multiple times at the NLP Summit. Can you tell us and share about some successful applications of NLP that you have seen within Merck?
Yeah, so at Merck, we see applications of NLP across the end-to-end value chain. That is starting from research and development, be it regulatory safety
Mhm.
or manufacturing, marketing, also in terms of the business process automation as well.
Mhm.
So if I look at R&D, typical applications falls in the areas of for developing search engines, for searching information in literature, patents, clinical trials, right? So kind of very traditional in nature, but more advanced in the sense moving away from a traditional search engines to more semantic, building up more semantic search engines, or kind of building even more Q&A, question answering systems. And there are some use cases or some examples that fall in the intersection of R&D and you can say even marketing. For example, we have been applying NLP for understanding the customer inquiries, to understand the voice of customers, understanding unmet needs, any kind of gaps expressed by the customers, typically which are coming to us through multiple channels like emails, call centers, and so on. So the idea is that we are able to understand the voice of the customers, and we are able to cascade the information back to the R&D so that they can take any decisions in terms of product strategy. It could be anything around marketing practices, right? Availability, and so on, right? Pricing. Um, and then if I look into the more regulatory safety kind of fields, we had rolled out a solution back already almost 5 years before in the regulatory domain for analyzing the product dossiers, especially information extraction from the product dossiers, product composition documents, very much around automating the processes of structuring the regulatory documents so that they are more ready for integration with other legacy regulatory data sets, databases, and which can be then submitted back to the health authorities, or at least we are kind of trying to prepare for submission to the health authorities. Of course, safety is also one of the use cases too that we have been working on. Less around identification of adverse events, but more around identifying kind of more causal effects around adverse events, right? For instance, more understanding the temporal associations around adverse events. So in this way, we have been trying to also scout around the space as well, trying to ensure to offer a decision system for the safety experts so that they're able to identify information around adverse events that has happened. If I look into the manufacturing domain, here we speak about manufacturing problems, manufacturing deviations, so
Mhm.
that we are able to help our the site operations to define better corrective and preventive actions, right? Better root cause investigations, so that with an objective that we are able to minimize the deviations as well. So the better the investigations, better the capas, naturally the lesser is going to be the deviations. And then if I look at the marketing commercials kind of field, here we speak about social media intelligence, market intelligence, again, trying to screen the social media websites and trying to understand the voice of customers, patients, any kind of unmet needs that has been expressed, any kind of gaps, right? So that we are able to, again, cascade back the information to the R&D folks so that they're able to define the right product strategies, and also very much around competitive intelligence too, right? So how are we positioned in the market in comparison to our competitors? Is there anything that we can learn, or we can better position our products and our services, increase our transparency and visibility in the market? So this kind of goes in the direction of commercials and marketing. And then with respect to the automation and business process operations automation, right? Here we speak about things like processing the invoices and bills, right, which is coming to us from multiple vendors, for instance, and typically document-based data. And how can we now automatically extracting all the information, all the fields, the key value pairs from this document, so that we are able to more automate the process of all these data entry processes, so that we can minimize any errors, and we can also be compliant with respect to the data quality that we have in our systems. So I think in this way, I think NLP is quite generic in nature. It can be applied anywhere, given that we have textual data at hand. And of course, we have been able to leverage NLP quite successfully across different subsectors and domains in the organization.
Yep. Yeah, I think definitely Merck has been a very successful early adopter of NLP kind of in practice. It's very interesting to see. Absolutely. So on the other side, what do you see as the main challenges of applying NLP today?
Yeah, so the challenges can be categorized into technical and non-technical challenges. So when I speak about technical challenges, so languages is something that we still see as a potential barrier. So although NLP is quite strong in English and a lot of European languages, when you speak about more Afro or Asian languages, I think that's where there is still a room for improvement. And if you now speak about a specific domain within this Asian languages, for example, if you speak about a traditional medicine in a specific region, right, for instance, so I think that's where the NLP is not, I would say it's rather evolving, right? It's still not there up to the mark. And the second thing is about the data quality as well. So we had to sometimes deal with the very low quality data, for instance, scan documents. And of course, we do a lot of trial and error with different types of OCRs in the market, right? Open sources, commercial. But sometimes the quality of data is so poor that unfortunately, even I, as a human being, cannot read this document. So I don't expect any magic to be coming from a machine.
Yeah.
So that is something, I think that's a common problem for all the companies, I would say. Then the lot of analog data that we speak about. So there is again expectation that NLP can also deal with analog data. That's not the case, which means if you have data as papers, right, paper sitting in the shelves, of course that's what we cannot help with. So there is a lot of digitalization work, foundational work that has to be done to at least make the data digitalized and to be usable for NLP as well. That's one of the challenges that we typically see.
Yeah.
And the most important one is the whole field of regulations, right? Regulatory applications as well. Although we have been successfully able to roll out applications in the GXP domain with qualified infrastructures, validated systems, and so on, it is still a human in the loop retrospective validation in place, which means it's not fully automated. There is always still an expert at the end who is looking at the results and then who is validating before the results are then used for any decision making purposes, right? So that full level of automation is still hasn't come, although authorities have been working on this, and we see a lot of user group meetings kind of called out by FDA and WHO and such organizations too. And I think we still have some time until the NLP can be implemented in a way that is fully automated, right, without any human intervention. So I think there is still a lot of time to come where NLP can reach that level of maturity. And I think general explainability is also a challenge I see. So explainability for a data scientist is different from explainability for a non-data scientist or for a regulator or an expert.
Yeah.
And of course, we do play with things like weights and biases, right? We have several, let's say, ways to kind of identify the hints around why a machine has done a specific prediction, very much centered around mathematics, right? or yeah, maybe some weights and so on. But unfortunately, this is very hard to explain to a non-technical expert. So I think making the explainability field more simplified for non-technical experts, I think that's basically one of the challenges that we typically see, and also we see a potential hope for evolution as well.
Yeah.
And then, of course, there are non-technical challenges too. So one example is an over expectations. So often the expectation is the machine is able to achieve a human accuracy in the range of 95+%, and that is not always the case. And we always stick to a rule of thumb of 80/20, which means 80% accuracy is still kind of still a good model to be used.
Mhm.
But it's not always the case that in some use cases or some problem statements, there is a need for a very high accuracy. As I told you, it's closer to the human accuracies, which may not be possible. Simply the problem statement is so complex, and that's what we see. And then very much around the whole hype nowadays happening in the market around the large language models. Although I don't want to name them, of course you can imagine, you can guess. It's a good easy to guess. There are many large language models out in the market as well, and there is also sometimes a myth that it can solve all the problems, right, of the company, but that's not the case, because we need to understand the fundamentals of the transformer models is that they come with a fixed vocabulary. So this means that you cannot teach a large language model, any kind of language model, a completely a new domain language unless it is trained from scratch, and which is not easy to do. So this means that if you have any conventional codes, conventional, let's say, identifiers, names that are used in my data that is known nowhere in the world, I don't think any language LLM or even shallow models can do the job, right? So that's something that people need to understand, and that's not happening, unfortunately,
Yeah.
right? And yeah, and I think these are some of the things that we see. And I think the last challenge I typically see is all about the literacy as well, right? I see people training transformer models like BERT models on 1,000 rows, right? And it doesn't make any sense, because you are trying to now fine tune a large or a relatively a large language model against a very small corpus of documents. And we typically end up in a mathematical underrun, right? Underflow, right? Which means you're adding so small numbers that your neural network doesn't do any adjustments. And people are doing this, unfortunately, right? People have been training BERT models for trying to fine tune on 100 rows or even 1,000 rows, and ending up with nothing. And this is also an unfortunate situation. I see that people have been publishing thousands of large models, medium-sized models, without a proper education of what's the right convention to use these models as well. So I think it's a mixed, I would say, technical, non-technical expectations. Yeah, hard to see, but yeah, let's see how things goes.
Yeah, no, I think you've surveyed the range of issues well. Yes, so there definitely, yes, a lot of things get published and shouldn't, yes, and a lot of just education, yes, on the data science side.
Yeah.
I definitely also agree with you on explainability. I would say yes, explainability to an end user is a completely different technical problem than basically having debugging tools. And expectations, yeah, that's the issue in every software technology, right? People not really know what to expect. Yes, yeah, it's so yeah, but we have a few more decades to figure this out. Yes. So if we don't look decades, if we look at where do you think we'll be in 3-4 years?
Yeah, so I think the language models, especially the large language models, or I would even say maybe medium-sized language models, right? So I think it's going to be mostly the generative models. I think that's going to become more integrated into the day-to-day business. So I think it's going to become more accessible for the end users with
Mhm.
little to no technical experience. Uh, I think that is one area where I can see things have been evolving quite rapidly. Then I think the second piece where things are evolving quite rapidly is also in the areas of kind of semi-automated labeling, machine-augmented labeling as well. For example, that's what you have been offering for example, NLP lab, what you have been offering, right? So kind of similar technologies have been evolving in the market too. It's all about helping and ensuring that we are able to create this label data in a more automated fashion with very little minimum efforts too. So using the concepts of weak supervision, active learning,
Mhm.
or maybe some hybrid techniques as well. I think that's one area where I think things are evolving quite rapidly, and things will change over the next 3 to 5 years. And also, I think the regulatory norms around use of AI models too, right? So, for instance, World Health Organization is organizing a user group meeting. Um, I think there was one happening last year as well, and of course, Merck was one of the representative too. And it's all about ensuring that we kind of come up with some ethics and good practices so that we're able to apply the AI/NLP kind of models in a regulatory domain as well. So I think that is something that is also, I think, gaining the attention of the authorities, so that we have right policies in place or right kind of guidance in place, so that we are able to more easily apply these models in a controlled, regulated environment too. And last thing is about the overall best practices and governance, as I explained, right? So I think the whole field of transformers is getting populated so rapidly. I think hundreds of thousands of models being published on the internet, unfortunately, without having any guidance of how to use it, what should be the right way to use it, right? And I think that's something where at least I hope that there will be some movement happening, that is to have some more curation, to having some good practices around the best ways and best conventions to use this language models as well. Yeah, I think these are some of the areas where I think next 3 to 4 years things will be more going in the direction of.
Okay, interesting. So Harsha, thank you. This was very comprehensive. Thank you very much for sharing your knowledge and your expertise. Definitely a very broad perspective. And as we said, I mean, you've been in this field for like a decade post PhD, so you've seen kind of you've seen this change, and you're also, I think, uniquely positioned within Merck to see really quite a few of the applications at the same time. So thank you. And I hope we get to do this again at some point. And everyone else also, thank you very much for joining us today. If you want to learn more about healthcare NLP, the Healthcare NLP Summit is coming up on April 4th and 5th. We'll be able to hear from more than 30 expert speakers about state-of-the-art NLP applications in healthcare and life science. It's a free virtual event, and we'll share a link to register, and hope to see you there as well. Until then, till next time we meet, thank you very much, and goodbye.
Thank you.
Thank you.